If you try to observe, this is a composite function. So this function has to be taken as t, not the complete function, but if you try to observe this cos of x which is there, its differentiation will be sine x. So if you try to differentiate this cos, you'll be getting sine. Therefore, what I'll be doing is I'll be taking this cos x to be equals to t. That is how we are going to do. So put the value of cos of x to be equals to t. Let us try to differentiate this one. Differentiate. So cos of x differentiation will be minus sine of x into dx will be getting is equals to derivative of t will be dt. Is this step clear? But do you have negative sign here? Negative sign is not there. If you try to observe over here, it is a positive sine x, positive dx. So which means this negative has to be removed. Therefore, I'll try to just multiply by minus of 1 on both the sides. So minus of minus will become plus sine x into dx. Right hand side minus 1 multiplied by. So this minus is multiplied by this minus, and minus is also multiplied by dt. Minus 1 into dt will give you minus dt. So minus goes on the right hand side. Now if you try to plug in back there, in the integral, I will be equals to. So we have integral of. First I'll write down this one. Sine of cos. Cos is what? Cos is t. Cos x is t. So I got sine t. Remaining value is what? Sine x into dx. Sine x into dx, we got it as what? Minus dt. We have replaced it. But minus sign you can take it outside. Minus if you take it outside, you'll just be getting sine of t into dt. But we know the integral of sine x into dx. Integration of sine x into dx will be minus cos x plus the constant c. That is the basic formula, right? Now if you try to substitute over here, integration of sine will become minus cos. So minus cos, here it is t. Minus cos t plus the constant of integration c. But minus of minus will become plus cos t plus the constant c. But what is the value of t here? T value that we have taken is what? T is cos x. So replace the value of t as cos x. Hence, we'll be getting cos of cos x plus c. That will be the required solution. Now another integral that we are having, we have to evaluate this integral. Square root of ax plus b. Again, the substitution is because under root whatever the value is or under square whatever the value is, you have to take that value to be equals to t, right? So put the value of ax plus b to be equals to t. So we'll try to differentiate this one. So differentiate this one, a into, now x, when you're writing derivative of x, you just write it as dx. Plus b is a constant, constant derivative will be 0 is equals to derivative of t will be dt. But you don't have a into dx. You have only dx. Therefore, you have to get dx there. So you can rewrite this as a into dx. You can ignore that 0 and write it as dt. Or dx will be equals to cross multiply, you'll be getting 1 by a into dt. This value you can substitute back in the given integral. Therefore, we'll be getting I is equals to, it is integral of root under root ax plus b value is t. Dx value is 1 by a into dt. But 1 by a is a constant. You can remove that 1 by a outside and write down integral of root t into dt. Right? Now the question is, what will be integral of root t? It is better you try to remember the integral of root t directly. But here, because we are dealing with the root for the first time, I'll be showing the entire procedure. So root always represents to the power of half. Root represents to the power of half into dt. And we know this formula, integral of x power of n into dx will be equals to x power of n plus 1 by n plus 1 plus the constant c. So in this case, also you can write 1 by a as it is, t power of n value is half. So we'll be writing half plus 1 divided by half plus 1 plus the constant of integration c. Or further, if you try to simplify this one, it is 1 by a t power of half plus 1 will give you 3 by 2. Denominator also 3 by 2 plus the constant c. Or further, if I try to simplify 1 by a, 3 by 2 in the denominator, if I take in the numerator, it becomes 2 by 3. And this t power of 3 by 2 will remain as it is. But what is the value of t I had taken? T value I had taken as ax plus b. So plug in that value back there as ax plus b. So this t will be ax plus b to the power of what? To the power of 3 by 2. And here this 2 times of 1 will be 2 divided by 3 into a will be 3a plus the constant of integration c. So that will be the required solution. Getting this one? Any questions? Yes, Amal, are you getting?
Yes, sir. Yes, sir.
Okay, another type of problem. X into x root of 1 plus 2x square. One plus 2x square. So therefore, once again, the value which is inside the square root, this value has to be taken as t. So put the value of 1 plus 2x square to be equals to t. Let us try to differentiate this one. Derivative of 1, the constant will be 0, plus 2, the constant as it is. X square differentiation will give you 2x into dx. So derivative of x square will be 2x into dx, and derivative of t will be dt. Or if we try to ignore this 0, it's 2 times of 2 will be 4. 4x into dx will be equals to dt. But if you try to observe over here, you don't have 4. You just have x into dx. So it is better you try to remove that 4. So send that 4 on the other side. If you cross multiply, you'll be getting 1 by 4 into dt. Now plug in this value back there in the given integral. You will be having I is equals to, it is integral of x dx under root. First I'll write under root. 1 plus 2x square will be t. The remaining value that is left out is x into dx. And this x into dx can be replaced as what? 1 by 4 into dt. 1 by 4 into dt. But however, 1 by 4 is a constant. I'll remove outside. You're getting integral of root t into dt. Now the question is, again, it is similar to the previous problem. So I need to write down this as t power of half into dt and use the same formula what I have shown you. Integral of x power of n into dx will be nothing but x power of n plus 1 by n plus 1 plus the constant. If you use that one, it becomes t power of half plus 1 by half plus 1 plus the constant of integration c. But half plus 1 value, half plus 1 value will be 3 by 2 plus the constant c, or 1 by 4 into 3 by 2. If I take in the numerator, becomes reciprocal. And what is the value of t I have taken there? The value of t that I have taken in this case is 1 plus 2x square. 1 plus 2x square. 1 plus 2x square to the power of 3 by 2 plus the constant c. You can cancel out over here. 2 ones are 2, 2 twos are 4. Or if we try to simplify, it is 1 by 3 times of 2 will become 6 into 1 plus 2 x square to the power of what? 3 by 2 plus the constant c. So that will be the required solution. Getting it? Any questions?
Yes.
Yes. What is your question?
No questions, sir. Got it.
Okay, fine. Let us take the next set of questions. So evaluate the integral. Integral I is equals to, so the question is what? X by root of x plus 4. X by root of x plus 4, where the value of x is a positive value. It's a slightly different problem than compared to all the other problems that we have done over here, right? So if you try to observe here, this cannot be expressed in the form of f dash of x by f of x into dx. Because if I take the numerator x plus 4 under root which is there as t, derivative of this x will become dx is equals to dt. So here dx will come. So dx is equals to dt. But along with the dx, x has to come here. But in this case, x will not come. So the additional x is there. What has to be done? Now this kind of situation you'll try to face whenever the power of x in the denominator and the power of x in the numerator are the same. You can see the power of x in the numerator is 1 and the power of x under root is 1. So in that case, what has to be done? You make the numerator and denominator as the same. Under root denominator value is what? X plus 4. Can I make this numerator also as x by 4? Is it possible? Can I make the numerator also as x by 4? What is the procedure I need to adopt to make the numerator also as x plus 4? How can I make x? How to get plus 4 there in the numerator? Is it possible? Is there any steps that I need to follow to get plus 4 there? Can you guess how to get plus 4 there?
We can replace this by x plus 4, right? And without taking the root.
No, we cannot do that one, right? So the best way is you have to add and subtract. Add and I'm writing in short, add and subtract 4 in the numerator. That is the only possibility that you have. So that you can get x plus 4. So what happens? Let us see. X plus 4 minus 4 whole divided by, it is under root x plus 4 into dx. Now, if I just try to cancel out this 2, I'll get back the question. So question should not be affected by addition and subtraction of that value. So I'm adding and subtracting. Whenever you have this type of problem, this is the procedure that you need to follow. Getting this one? Even if you have like one more example, I'll try to give x by x plus 2. Even in this case also, you'll be doing the same thing, right? Or the other way is, suppose you're having x by x plus 2 whole square. Even in that case also, you'll be doing the same thing. Getting it?
Yes,
Because
sir.
from only one problem, there are so many other problems that will originate. So you should be able to get, because I'll be doing this one type of problem. If similar type of problems comes over here. So the best way to check whether this procedure has to be followed is the numerator power and the denominator power will be the same. Check it. Right? That is the clue for you to add and subtract. Getting this one?
Yes, sir.
Now what I'll try to do is I'll group the first two. And this I'll try to separate that minus 4 well. So how is that? I'm grouping this x plus 4 together. Minus of 4 I'm writing separately, divided by root of x plus 4 times of what? Dx. Now what I'll try to do is I'll try to divide this x plus 4 by root of x plus 4 minus this 4 is there again 4 separately. I'll try to divide that by root of x plus 4 into what? Into dx. This is how I've done it. Now, because there are two terms, according to the properties of integration, I can apply integration separately for the first term, that is x plus 4 divided by root of x plus 4 into dx minus. Again, you can apply the integral for the second term. It is integral of 4 is a constant, I'll take it outside, 1 by root of x plus 4 into dx. This is how we can separate the integral. But the numerator which is there, this x plus 4 can be written as root of x plus 4 into root of x plus 4 whole divided by, it is root of x plus 4 into dx minus 4 times of, you're having this value to be equals to, it is 1 by root of x plus 4 as it is into dx. But we observe that root of x plus 4 and root of x plus 4 will cancel out and you'll just be left out with, it is integral of root of x plus 4 into dx minus, it is 4 times of integral of 1 by root of x plus 4 into dx. So this is how you can just separate it. Now you can integrate this one or make the substitution for both the cases. If you want to solve separately, then you can write this integral as I1 and I2 and solve it. But I don't think it is required now. We'll try to solve it directly only. If required, we'll try to use it. If not required, we'll not use it. Therefore, the substitution is common here. Therefore, put x plus 4 to be equals to t in both the terms. Now let us try to differentiate this one. Derivative of x is dx plus 4 is a constant, derivative will be 0 is equals to dt. Right? Just one moment, hold on.
Yes, sir, got it. But like here, shouldn't we have taken a different value for dt then? No, for t then. If dx is coming equal to dt. Oh, yes, sir. Right. Sir, is it? So, sir, are you there?
Yes, what was your question?
Sir, what happened?
Yeah, what was your question?
No, so like, shouldn't we take a different value for t? Because like, if you're getting dx equal to dt, that's some issue, right?
You take a different value where? Instead of t, you want some other value. You can take, because what we are doing is, if you want, you can even take some other value, but for x plus 4, we are taking it as t. If you want, you can even take x plus 4 to be also equals to u. But since for all the problems we are using t, we'll continue with t itself. If required, we'll try to take some other values. But here, because both the values are the same, x plus 4 and x plus 4 both are the same only. For both the values, I can take only one t. Right? Suppose if you're having here as x plus 2 and here as x plus 4, then I would have taken one as t, another as 4. Like I would have used, suppose if you had x plus 2, for that I would have taken t. For x plus 4, I would have taken, say, u, or I would have taken this as t1 and t2, or u1 and u2, in that way. Because both the values are the same, I am taking for both one single value t. Getting it?
Yes, sir.
So now if I go back and substitute this value back there in the given integral, I'll be getting integral I to be equals to, I is equals to this root of x plus 4 will become t. Dx will become what? Dx will become dt minus 4 times of, again, integral 1 by root x plus 4. X plus 4 is t into dx. Dx is dt. But root has to be eliminated over here. I can write this root as to the power of half dt minus 4 into integral of this 1 by root represents to the power of half times of dt. I can use the formula. Since I know this formula, integral of x power of n into dx is nothing but x power of n plus 1 by n plus 1 plus the constant c. Therefore, it is t power of half plus 1 divided by half plus 1 minus this 4. It is integral of. But t is in the denominator. I can take this t in the numerator. The moment I take t in the numerator, positive power will become negative power times of dt. So because I'm integrating, and I can add the constant of integration as c. Therefore, it is t power of half plus 1 will give you 3 by 2 divided by 3 by 2 minus 4 times of. Once again, you can use the same formula, whether the power of n is positive, whether this value power which is there is positive or negative, I'll be using the same formula. T power of n value is minus half. So it is n plus 1 divided by n plus 1 plus the constant c. Or further, if you try to simplify this one, 3 by 2, when it comes in the numerator, it becomes 2 by 3. And this value of t that I have taken here is x plus 4. So it becomes x plus 4 to the power of 3 by 2 minus 4. It is t power of 1 minus half will be half only, divided by denominator also 1 minus half will be half only, plus c. Or further, if I try to simplify this one, it is 2 by 3 into x plus 4 to the power of 3 by 2 minus 4 into this half in the denominator. When it comes to the numerator, it becomes 2 by 1. And the value of t that we have taken is x plus 4 to the power of half plus c. Or you can write 2 by 3 x plus 4 to the power of 3 by 2 minus 4 times of 2 will give you 8. 8 into x plus 4 to the power of half plus the constant c. So that will be the required solution. Getting this one?
Yes, sir.
So all this other three cases that I have shown you over here, right? So this two examples that I have given you, this you can take it as a homework. Follow the same procedure. This one. This you can try as a homework. Follow the same procedure what I have shown you. Here we'll be adding 2 and subtracting 2 in both the cases. Here I have added 4 and subtracted 4. In these two problems, we'll be adding 2 and subtracting 2 and follow exactly the same procedure. And try to see what's the solution we'll be getting there. Right, another type of problem. Again, this is also quite different. Evaluate I is equals to, you have integral of x cube minus 1 whole to the power of 1 by 3 x power of 5 into dx. X cube minus 1 whole power of 1 by 3 x power of 5 into dx. Now the question is, which value I need to take as t? That's the question. If I take x cube minus 1 from x cube, you will not be able to get x power of 5. From smaller power, you cannot get a greater power. But from a greater power, you can get a smaller power. So possibility is that I can take this as t. But if I take this as t, if I try to differentiate x power of 5, derivative of x power of 5 will be what? It is 5x power of 4. Power 4 should be there, but you're having power 3. What has to be done? That's the question. So which means that I have to simplify in this way and try to make this value also in terms of x power of 3 or x power of 4. That is what we need to do it over here. So the question is, can we put this value as, rewrite this one, x cube minus of 1 to the power of 1 by 3. So the least power that you can make, however x power of 5 you cannot take it as t. But the question is, can I put this as t? So this is ruled out. But can I take this as t? But if I take this as t, differentiation of d by dx of x cube will be what? 3x square, which means x square should be there here. So x cube should be there and x square should be there. Both should be there. Only then you'll be able to integrate this one. So can this x cube x power of 4, whenever the bases are the same, powers can be added, x power of 5. That is, this value he has given. So can I convert this x power of 5 back in this form, x cube into x square, so that I can solve this problem? Are you getting it? Directly it's not possible. You have to use your brain here. From now on, if you want to solve any problems on integration, you should be alert and your brain should work. Only then you'll be. Till now, it was plain, simple problems, direct problems. From now on, a bit of analysis you have to do whenever you're trying to solve the problem. Is this idea? Are you getting it? Just by seeing the problem, you'll not get it. Only when you practice, you'll get this idea. Because very first step, how will you get this idea? Is this clear what I'm telling you?
Yes, sir.
So very cleverly this problem has been prepared. So x cube minus 1 to the power of 1, because I have decided that I'll be taking x cube as t. I have to put x power of 5 as x cube into x square. I'm just breaking that one. X power of 5 is written as x cube into x square into dx. So that if I put this as t, all right. So if I put this value as t and this value as t, I have to get that x square term. But there are two t terms. Can I take two t terms values? Is there a possibility that I can take both t terms values to solve this one? That's the question. So can we solve this problem by taking two t values? Because we'll be getting a product there. Again, that is a confusion you'll be having there. So is it possible to solve it just by taking two t values? Do you have any idea of taking two t values? Again, a few trickish uh, steps you have to apply over here so that you can solve this problem. All right. So let us try to simplify this one further and see how exactly to solve this one. So let me solve this one. So first we have taken x cubed. Let us go ahead and then try to take this value. So very first step will not be able to. So this is done. The next step is put the value of x cubed to be t. If I try to differentiate this one, derivative of x cube will be 3x square and differentiation x square will be getting. So x cube differentiation is 3x square into dx is equals to what? Is equals to dt. But what you're having over here, you're having x square into dx. Therefore, what you can write is, you can write x square dx to be equals to dt. X square dx will be equals to what? Dt by cross multiply, dt by 3. So now you try to plug in this value back there in the given integral and see what can be done over here, right? So if you just try to plug in there, I is equals to, you got it as integral of t cube is what? X cube is what? X cube is t. T minus 1 to the power of what? To the power of 1 by 3. Then x cube value is what? X cube value is t into x square dx. X square dx is dt by 3. Is this clear? Till here, it is one part of the problem. One technique that we have used. Any questions, any doubts in this part?
No, sir, no, sir.
Is it clear? Now we'll move on to the next part. Okay, so try to observe over here. Here t minus 1 is there and t is there. So one should be the derivative of the other if you want to once again go for the substitution method. So is it not similar to the previous problem? Here the power of t is 1. Here the power of t is 1. So whenever the power of t is 1, here the power of x was 1. Here, can you observe? The power of x was 1. The power of x was 1. So what we have done, in the denominator we had x plus 4. Numerator also we have brought it as x plus 4. This is in terms of x, but now we are getting in terms of t. Here you are getting t minus 1. You have to make this value also as what? This value also as t minus of 1. Right? Both the values have to be made as t minus 1 itself if you want to solve this one. Because directly you cannot simplify this one. Therefore, I'll try to simplify this. Divided by 3, I can take it outside and write down t minus of 1 whole power of 1 by 3. I'm adding, subtracting 1 and adding 1. Subtract and add 1. Is this step clear? Because still here, this is one way of solving. From here, and this way will slightly change. Right? Any questions here?
No, sir.
Okay, now I'll try to group t minus of 1. So if you try to group this one, it is 1 by 3. It is t minus of 1 whole power of 1 by 3. I'll write down this value to be equals to, I'll try to group this. T minus 1 I'll try to group. Plus this 1 I'll try to separate into dt. I think this divided by 3 I've already taken common outside. Okay, I have already taken this 1 by 3 common outside. Again, there is no need to write. Okay. Now, what has to be done is, once I have grouped this grouped value has to be multiplied by this t minus 1. So this will be 1 by 3. It is integral of t minus of 1 whole power of 1 by 3 is multiplied by t minus of 1. That is one product. Again, plus you are having. Plus, again, multiply this value, t minus 1 whole power of 1 by 3 with 1. So you will be getting another value, which is t minus of 1 whole power of 1 by 3 multiplied by 1 will be t minus 1 whole power of 1 by 3 itself. Into what? Into dt. Now, since there are two terms over here, I need to apply the integral separately for each of the term. 1 by 3 integral of. Now, this is t minus of 1 whole power of. This is 1 by 3 and this is power 1. So this becomes t 1 by 3 plus 1 into dt I can multiply. This dt will come inside. So 1 integral plus again 1 by 3 for the second term. 1 by 3 is outside. Integral of t minus of 1 whole power of what? Only one term is there, to the power of 1 by 3 into dt. Or further, if I try to simplify this one, 1 by 3 integral of t minus of 1 whole power of 1 by 3 plus 1 will be 4 by 3. 4 by 3 into dt plus 1 by 3, it is integral of t minus of 1 whole power of 1 by 3 into dt. Again, if you want to make the substitution over here, you can make the substitution. Put the value of t minus 1 to be some other term u. Both are t minus of 1. Now let us try to differentiate. Differentiation of this t will be dt minus 1, the constant will be 0, is equals derivative of u will be du. Therefore, dt will be equals to du. So go back to the given integral. 1 by 3 integral of t minus of 1 will be u power of 4 by 3 into dt will become du plus 1 by 3, again integral of t minus of 1 will become u power of 1 by 3, dt will become du. We know this formula. Integral of x power of n into dx will be nothing but x power of n plus 1 by n plus 1 plus the constant c. If I use it, 1 by 3 u power of n value is 4 by 3. 4 by 3 plus 1 divided by 4 by 3 plus 1 plus 1 by 3. Again, u power of 1 by 3 plus 1 divided by 1 by 3 plus 1 plus the constant of integration c, or 1 by 3 u power of 4 by 3 plus 1 will be 4 plus 3 is 7, 7 by 3, whole divided by 7 by 3 plus 1 by 3 into u power of 4 by 3 divided by 4 by 3 plus the constant c. But we know the value of u. What is the value of u? You have u value is t minus 1. Over here, u value is t minus of 1. So put the value of u as t minus of 1. This 1 by 3 as it is, 7 by 3 will become 3 by 7. So u value is t minus of 1 whole power of 7 by 3 plus 1 by 3 into 4 by 3. When it comes to the numerator, it becomes reciprocal. U value is t minus of 1 whole power of 4 by 3 plus the constant c. You can further simplify this one. This 3 and this 3 will get cancelled. This 3 and 3 will get cancelled. But what is the value of t that I have taken initially? If you go back, t value over here, I have taken t as x cube. So put the value of t as x cube. So you will be getting the value as x cube minus of 1 whole power of 7 by 3 plus this 1 by 7 is there. I'll write 1 by 7 as it is. Here you are having 1 by 4. T value is x cube minus of 1 whole power of 4 by 3 plus the constant c. So initially the question was in terms of x. Finally, you have to express the solution also in terms of x only. That's the required solution. Getting it? Any
Yes, sir.
questions? So you need to practice it because integration
Sir, could
form.
you explain the part like where you took the dt value, the t value? Like how do you choose the t value correctly for each?
This one x cube as t.
Like how do you decide what will take as the t value?
That's what. T value directly you'll not be able to find out. This was the question, right? First I decided that I'll be taking this value as t. First I decided because x power of 5 is there, it is independent. I thought of that. I thought of taking that as t. But the moment I try to differentiate here, it has become x power of 4. The moment you try to differentiate, this value which is there should appear here in the question, because everywhere, wherever you have to try to differentiate, what we have got that value there in the question itself. For example, here x square was there. When I try to differentiate 2x square, I got x dx. 2x square, if I try to differentiate, I got x dx, right? So when you try to differentiate that one, its derivative should be present there. That's the formula you're having. But in this case, what is happening? X power of 5 is there. X power of 5 is there. But the moment I try to differentiate x power of 5, I'm getting x power of 4 here. But there is no x power of 4. So that will fail. Therefore, I decided differentiating x cube. If I differentiate x cube, I'll be getting x square. But x square is also not there. That will also fail. Now the question is what to be done. But x cube, you can take t. But if you want to take x cube, how can you express x power of 5? So therefore, I have expressed x power of 5 in terms of x cube. I have written this 5 as I have to get 3. So 3 plus 2 will give you x power of 5. So further I have written it as x cube into x square. And we know when I take x cube, this as t, I will be getting its derivative, x square. Therefore, this is one of the possibility where I have expressed x power of 5 as x cube into x square. Then I have decided x cube as t. So one first step will not be able to identify which value has to be taken. So you have to use some methods here. So first I have checked with x power of 5, that was not possible. Then I checked with x cube, that was also not possible because x square was not there directly. So I have thought of getting how to get x square. The only possibility is by splitting x power of 5. When I have splitted this x power of 5, it has become x cube and x square. And x cube I have taken t. The moment I have taken t, I am getting that x square into dx, its derivative value. This is how you need to decide. But the moment you see the problem, you will not be able to get it. Alright, one way is power is high. First set of problems that we have done. Power is more. Power is more means like you are having x square, its derivative is present as x. X cube is there, its derivative present as x square. X power of 4 is there, its derivative present should be x cube. But if the power is less, in that case, the less power value you are taking it as t, more power reduced to less power. More power reduced to less power value. That is what I have done. This method I have adopted because this was not possible for us in this problem. So these are the two possibilities that you remember. When power is more, the moment you try to differentiate, you'll be getting that value. But when the power is less, when you're not able to get the value, then try to check whether the more power values like x power of 5, can you reduce that in the smaller power form? These are the two possibilities you have to check. Only then you'll come to know that you have to take how to take t value. Getting it?
Yes, sir.
Just by seeing the problem, you'll not be able to get it. You have to check 2 to 3 steps to arrive at the result that which value has to be taken as t. Getting it? Just try to practice this once again at home. Try to change the powers and see what are the other possibilities that you'll be getting in this case. So if you want, you can try with this one, integral of x square minus of 1 whole power of 2 by 3 into, and we take this as x square means you have to get this as x cube into dx. You try this one as a homework. You'll get an idea on how to adopt this procedure.
Yes, sir.
All right. First you practice with the same problem itself, and then you try with this one and check out. Because this type of problems, only by glancing you will never be getting this type of problem. You have to take pen and paper and solve it. And try to prepare similar problems and try to solve it. Only then you'll be getting an idea. All right. It's already time. We'll wind up the class again. In the next class, we'll try to continue with the same topic. All right.
Yes, sir.
Okay then. Goodbye.